Hi Pre-Calculus. Today we're jumping into adding and subtracting rationals. So you guys know what adding and subtracting means, but if you're thinking about the word rational, they really just mean fraction. Has the word ratio in it, which means a comparison. A fraction is a comparison. So there are three sort of situations. The first one is where the denominators are already the same. It's going to be our easiest situation, where one of the denominators must be multiplied by a factor to make them the same, and then where both denominators have to be multiplied to make them the same. So we'll go through each one individually. So for the denominators always already being the same, this is what we would call having a common denominator, right? They both have the denominator of 12. So I can just do what's on top here. So 5/12 minus one of those twelfths would be 4/12. And I want to not forget to reduce if necessary. So dividing top and bottom by 3, by 4, I get 1/3. So 4/12 is 1/3. Similarly, we can also do addition in the same way. So since they're 15ths, 7/15 plus 3/15 would be 10/15. Go ahead and simplify that to 2/3. Right? So just a little reminder in adding and subtracting fractions. We can do something similar when our problem looks like this. We have 2x plus 3 over x squared minus 4 minus x plus 1 over x squared minus 4. So since these are like terms, we know the common denominator is x squared minus 4. And basically what I'm thinking here is I have this thing minus this thing here. Right? I can circle that. So I have 2x plus 3 minus the whole thing, x plus 1. Like that. The reason I want to put this in parentheses here is because the negative applies to everything over here. So I would have 2x plus 3, distributing that in, minus x minus 1 over, I'm just going to write the denominator for now because I still want to simplify here. So I have 2x minus x would be just 1x, and 3 minus 1 would be plus 2, right? Still over x squared minus 4, right? So we've effectively collected them, and we had two fractions and we subtracted them together and we got this as our answer. However, we do want to make sure that we reduce if we can, right? We want to not forget our reduction step. So I'm going to go ahead and simplify as we were doing earlier this week. So x plus 2, and then on the bottom, I recognize this is the difference of squares. So I'm going to go ahead and turn this into x plus 2, x minus 2, like that, because I know x squared minus 4 simplifies into, or factors into these two factors. And then I see that there's something common on top and on bottom. That leaves me with nothing in my numerator, so it simplifies to 1. So I have 1 over x minus 2. Right, so this here is going to be my answer. I want to be very careful that I don't forget to give my warning signs. So anything in the denominator would be x is what x is not allowed to be. So x is not allowed to be -2 and also not allowed to be +2. So I'm going to give that warning to my readers as well, that if my x is -2 or 2, it'll make the whole function undefined. So this is my answer for this first problem. So first I combined them into one fraction, right? I simplified, and then I canceled if possible. I wrote my answer, and then I wrote my warnings, right? So those are my basic steps as I'm working through. Okay. You might remember from earlier in your math career that when we have two fractions that have different denominators, we need to make sure that they have the same denominator before subtracting. So I can't just take 3/5 and subtract 7/15, right? I need to make them both have 15 in my denominator. I can do this by multiplying by 3/3. 3/3 is just 1, so it's not changing the number at all. It's just sort of putting it in a different disguise, right? It's putting in a more useful term. So I could say 3 times 3, that would be 9 over 3 times 5, that would be 15. So 9/15 is the same as 3 over 5. And now I want to subtract 7/15, and I get 9 minus 7 would be 2/15. Right, so 9/15 minus 7 of them would give me 2 of them. Simplify if I can. In this situation, I cannot. So we see if we have different denominators, we want to double check what they have in common, or how we can make them be in common, really. So for this one here, I'm going to start with my denominators by determining what my denominators are. So x squared minus 4, I recognize is the difference of squares. So I'm going to turn that into x minus 2, x plus 2. Right? This is a more useful format. This version here, or this denominator here, already has an x minus 2 and an x plus 2. This fraction over here does not have an x minus 2. It does have the x plus 2. So since they have x plus 2 in common, I don't need to multiply those because they both already have an x plus 2. However, this one also needs an x minus 2. And if I multiply it on the bottom, I also have to multiply it on top. X minus 2, like that. So now my common denominator, what they have in common is x minus 2, x plus 2, x minus 2, x plus 2. So they have x minus 2, x plus 2 in common. And then it's going to have this portion here, which we haven't touched yet, x squared plus 6x. And then don't forget this is a negative 2 being multiplied into each piece here. So negative 2 times x would be minus 2x. Negative 2 times negative 2 would be plus 4. Right, so be careful that that negative does apply to everything in here. So I'm going to combine like terms here, x squared plus 4x plus 4 over x minus 2, x plus 2. So I've done my addition subtraction step. Now I want to simplify if possible. So I'm going to go ahead and break this one into x plus 2, x plus 2. Right? Remember, this would be like what multiplies to get 4 and adds to get 4 would be 2 and 2. So that's how I got those numbers there. And then I'm going to bring over this step here, the denominator. And I look for something in common, which I see x plus 2 and x plus 2. One on top and one on bottom. Can cancel out. And I'd be left with x plus 2 over x minus 2. Want to be careful that I write my warnings. So x is not allowed to be 2 or negative 2. Right, so again, this is my answer portion here, and then my restrictions are there. These are called domain restrictions, what x is not allowed to be. All right. So as you can see, we want to do what we can to make the denominators the same. Okay. In our last example here, it says both denominators must be multiplied by at least one factor to make them the same. Right? So 12 and 15 can both be turned into the same number. And you might have learned in your past math life that you could do like times 15 and times 15 and times 12 and times 12. That's going to give you a really big number here, right? So what I don't know what that is, but a really big number. What might be simpler and what you might have learned in the past is to think of some numbers, or to think of a number that both of these, a bigger number that both of these could go into. So our least common multiple is what we call that, like in official math words. I know that 15 times 4 would give me 60, and 12 times 5 would also give me 60. So I'm thinking here, okay, I'm going to multiply each of them by their respective numbers. So I'd have 25 over 60 plus 16 over 60, and that would give me 41 over 60, right? And that would be my answer. Alternatively, if like just coming up with the number 60 seems strange, you can also say, okay, this is 5 over 12 plus 4 over 15. If you think about it, 12 is the same as 3 times 4. So I can turn my 12 into 3 times 4. And 15 is 3 times 5. Right, so 15 has been turned into 3 times 5. They already have a 3 in common. So what does the first fraction want in order to be similar to the second fraction? A times 5 and a times 5. Right? What does the second fraction want? They have a 3 and a 5, but they don't have a 4. So they get jealous, they want a 4, and multiply like that. And you can see we're going to have the same thing that's happening here. 25 over 3 times 4 times 5 is 60, plus 4 times 4, which is 16, over 3 times 5 times 4, which is 60. So we're going to get the same thing here. We're thinking about it in two different ways. So either you can sort of do that guess and check in your head, or you can break down the pieces and then figure out what they want in common. Okay. For our math today, we're going to use this version where we break it down and see what they already have in common so that we're not working so hard. We want to work smarter, not harder. So for example, this problem here, I'm going to go ahead and break down this denominator to see what's in here. So I see that they have 2x in common. So I'm going to factor out a GCF of 2x. That's going to leave me with x plus 1. That's my red denominator. In my purple denominator here, I'm thinking what multiplies to get negative 3 and adds to get negative 2? 3 and 1, negative 3. So I'm going to have, for the purple denominator, I'd have x minus 3 and x plus 1. Right? So when I look at these two denominators, I see they both already have an x plus 1. Right? They already have this x plus 1 here. Right? The red denominator has a 2x. I don't have 2x over here. So I'm going to put multiply times 2x on top and on bottom. Right? That's going to give me now 2x in common. So now they each have a 2x. And then you might think, okay, well, the red one's not going to get jealous because the purple one has both of the things that the red one has, but it needs an x minus 3. So it wants an x minus 3 and an x minus 3. Now the denominators, right? The denominators are the same. We have a common denominator. It's 2x times x plus 1 times x minus 3, right? We have the green, the yellow, and the red, all right? So now I need to do the numerator here. So I'm going to do this side first. So 3x times x, 3x times negative 3. So 3x times x would give me 3x squared. 3x times negative 3 is negative 9. I notice this minus here, so I'm going to leave the minus, and whatever's left, I'll distribute the minus in later. Right, so 2x times x would be 2x squared. 2x times 2 would be positive 4x. I'm going to go ahead and simplify here. I have 3x squared minus 9 minus 2x squared minus 4x. I'm going to simplify. So I have 3x and negative 2x would be 1x squared minus 4x minus 9 over 2x, x plus 1, x minus 3, like that. I'm going to go ahead and try to factor this if I can. I need two numbers that multiply to get negative 9 and add to get negative 4. 9 is 1 and 9. That's not going to work. It's also 3 and 3. That's not going to work. And that's it. So there's no way to factor this. And so I'm actually just going to leave it the way that it is. So this is my answer. And then I need to write my restrictions, what x is not allowed to be. X is not allowed to be 0 from this first one, negative 1 from here, or positive 3 from here. So in increasing order, negative 1, 0, and 3 would be my wording. Right, so this is my full answer to this problem. If you want to pause the video here, that's totally fine. You can go ahead and get started on your practice. If you'd like to see another example, I'm going to do another one here. So For this one here, my first step is to break up this part. So I see that they have an x in common. So I'm going to say x and then x minus 7. For my other denominator here, I have 2x minus 14. So I'm going to take out 2. I have x minus 7. So I can see, okay, they have an x minus 7 in common. I'm not going to worry about the x minus 7. It looks like this one has a 2. And so this one's going to want to multiply times 2. And this one here has an extra x. So we're going to multiply an extra x in here like that. So my common denominator would be 2 times x minus 7. So 2x times x minus 7. I'm going to go ahead and distribute here. So I have 2x. 2 times negative 3 would be minus 6. I have a minus. I have x times 4 would be 4x. X times negative x would be minus x squared. I'm going to go ahead and simplify by distributing in. So 2x minus 6 minus 4x plus x squared. Go ahead and rearrange and combine. So x squared. I have 2x minus 4x would be negative 2x minus 6. And I think, okay, I have negative 6, multiply to get negative 6, add to get negative 2. 6 and 1, not going to work. 2 and 3, not going to work. So I don't need to factor anymore. Just need to write my common denominator, 2x times x minus 7. So I have my answer there. My what x is not allowed to be, from 2x, that would be 0. And from x minus 7, that would be positive 7. So this is my final answer to this problem. Please ask any questions that you have. Looking forward to talking to you. Bye, guys.